Most diesel engines have one crankshaft. This one had three. And they were not lined up in a row. They sat at the three corners of a triangle, wrapped around cylinders that did not behave like normal cylinders at all. This was the Napier Deltic, one of the strangest diesel engines Britain ever built, and one of the few machines that genuinely looks like it should not work until you understand why it did. The story begins during the Second World War. Britain needed compact power for fast naval craft. A motor torpedo boat could not carry a slow, heavy industrial diesel and still do the job it was built for. It needed power density, a lot of horsepower in as little weight and space as possible. Napier already had experience with opposed-piston diesel ideas. In a normal engine, each cylinder has a piston pushing toward a cylinder head. But in an opposed-piston engine, there are two pistons inside the same cylinder, moving toward each other. The combustion happens in the space between them. That removes the conventional cylinder head, which saves weight and changes how the engine breathes. But it creates another problem. If there is a piston at both ends of the cylinder, both ends need to be connected to a crankshaft. The Deltic solved that problem in the most extreme way possible. Instead of laying the cylinders out in a straight line, Napier arranged three banks of opposed-piston cylinders into the shape of a triangle. At each corner of the triangle sat a crankshaft. Gears linked the crankshafts together and sent the combined power to the output shaft. From the outside, it looked less like a normal diesel engine and more like a mechanical puzzle. But the layout had a purpose. By folding three banks around each other, the Deltic packed a lot of working cylinders into a compact space. It was a two-stroke diesel, so every cycle produced power more often than a four-stroke engine of similar size. And because the pistons uncovered ports instead of using a normal valve train, the engine could breathe in a very different way. The result was not simple, but it was powerful. The Deltic became best known in two very different worlds. One was the sea, where compact high-output diesel power mattered. The other was the railway, where English Electric used Deltic engines in locomotives that became legends on British rails. To rail enthusiasts, the Deltic was not just unusual on paper. It sounded different. A high-speed two-stroke diesel with three crankshafts did not rumble like a conventional locomotive engine. It had a hard, urgent, mechanical scream, the sound of a design doing something very few engines were ever asked to do. So why did the triangle diesel not become the future? Because the same things that made it brilliant also made it difficult. Three crankshafts meant precision gearing. Opposed pistons meant unusual timing. A compact high-speed two-stroke diesel could deliver impressive power, but it also demanded knowledge, maintenance, and parts that ordinary engines did not. The Deltic was not a bad engine. In the right job, it was remarkable. But it was specialized. And as diesel technology improved, the world found easier ways to get reliable power without building an engine shaped like a triangle. That is what makes the Napier Deltic such a perfect forgotten engine. It was not forgotten because it was ridiculous. It was forgotten because it belonged to a moment when engineers were willing to solve a real problem with a machine almost nobody would dare to design today. Three crankshafts. Opposed pistons. A triangle full of explosions. And for a while, it powered warships and trains.